Welcome to another lesson that is part of the TI-30XB student course. In this lesson, we'll be looking at surds and exact values. One way we can get a surd answer is when we do a Pythagoras calculation. So let's calculate the hypotenuse for a triangle that has two perpendicular sides of side lengths 7 and 4. So in order to calculate that, we need to do the second and square root, because the distance, remember, is the square root of the sum of the squares of the perpendicular sides. So let's put those numbers in. 7 squared, right there, plus 4 squared. And we press enter. And we can see that we get this answer of the square root of 65. So this is an exact answer, or a surd answer. To find out how big that is, keep in mind your perfect squares, that the square root of 64 is 8. So this is just a little bit bigger than that, and we can find out exactly how much bigger by using the toggle down here above the enter. So I press that and it gives me the decimal approximation, 8.06 to 2 decimal places. So let's have a look at another triangle, this time with side lengths 3 and 9 as the perpendicular sides. So once again, my Pythagoras calculation will be second and square root. And if I have 3 squared plus 9 squared, and I press enter, oh, that's a bit different. I've got 3 times the square root of 10. That's what that's saying. So why did the one before come up as the square root of and the full answer, and this one got split into a part out the front of our square root sign? So what we need to think about is what that equals. Well, let's have a look at the decimal equivalent. It's 9.4868, etc. But if we have a look at these numbers, 3 squared plus 9 squared, we can see that we have got 3 squared plus 9 squared. We've got 90 in that square root. So let's do the square root of 90. And what we get is that 3 root 10. But if we think about that as 90 could be written as 9 times 10, what I've got is the square root of 9, and I'll use the right arrow to get out of that, and I'm multiplying by the square root of 10. And if I press enter, I get that 3 root 10. So here we have this situation where we can factorize what's inside the square root from 90 to 9 lots of 10. And we know that the square root of 9 is exactly 3. But the square root of 10 doesn't have an exact value. So we get that square root of 9 being the 3 out the front, or the coefficient of the square root of 10. And once again, if you press that toggle, you will see what that approximates to. Well, that's it for this lesson.